Hello everybody, Chris here, and in this video I wanted to show you how you can have enemies drop items onto the ground and a player pick them up inside of Godot 4 with my item drops plugin. So for this tutorial I already have the basics for a player that can move and enemies that we can deal damage to. And when they run out of health, they drop down to a death state, of course, which is going to be the perfect spot for us to add dropping items onto the ground. So to get started, you should make sure that in your Resources Add-ons folder that you have item drops installed. So we're going to go to Project Settings, Plugins, and we're going to enable item drops. Now we should be able to go into the Swordsman enemy, and if we right-click on the root of the scene, we should be able to find the drops component that we're looking for. So if we right-click here, Add Child Node, and you type in drops, you'll find a drops component as a regular node. So our drops component is going to have two requirements. Over on the right, you can see we need a drops table resource, which defines what the character can drop and what the odds of each item dropping are. And then the scene spawner, which puts the 2D node of the item into the physical game. So items are generally going to be represented as a resource, which is a pure data object. But if you want them to be picked up inside of the game, then they'll also need a 2D object, like a rigid body 2D. Inside the scene so that it can interact in the scene and be picked up by a player, for instance. So for the drops table, we can just click over here and do new drops table. And in the possible drops, we need a droppable. So let's create a new one of these. So this is an array. You can have multiple types of drops, and we'll create a new droppable. So our new droppable is going to take a drop. So the drop here is actually a packed scene. So you could really be instantiating anything you want into the game. You could create a new enemy as a drop if you wanted to. It doesn't necessarily need to be a pickup item. And then you can see the odds. So if you have a 1.0 odds, that means 100% of the time when it rolls on this drop table, it's going to drop this item. If you want that to be less than 100%, then just lower this somewhere between 0 and 1. So we'll leave that at 1 for now. And we'll need a new scene that we're going to drop. So to create our drop scene, I'm going to go up to Scene, New Scene, and we're going to choose Other Node, and I'm going to look for Rigid Body 2D. So the reason for this is that I want the dropped item to kind of interact with the physics engine, be able to be pushed around, and it can also have collisions with other objects like the pickup area that will eventually detect the rigid body and add it to the player's inventory. So let's choose Rigid Body 2D here. And then I'll add a sprite node as a child here so that we can actually see a visual for our dropped item. So add node sprite 2D. We'll also need a collision shape 2D. So collision shape 2D in order to define where the rigid body collides with other objects. And we can do on the right a new circle shape. So you can let your enemy drop whatever you want. I'm going to search for grass, and he's just going to drop a grass item for us. So I'm going to select grass 1, PNG, just whatever art you want to use here. And we can see that the collision shape is way too big for this. So I'm going to lower the radius to something more like 2 pixels. So I have tried this with a 1 pixel radius, but I've noticed that with 1 pixel circle radius that the object often gets stuck in walls and something like that. So I would make it at least a 2 pixel circle radius, or much bigger if you're not doing pixel art. So for the root of this scene, the rigid body, I'm going to just rename it to be grass. And then the last thing we need for this item is going to be a pickup component. So I'm going to right-click on grass, add a child node, and search for pickup. So we want the pickup.gd script here. And this component defines our scene, not just as a random 2D scene, but one that can be picked up, of course. So our pickup over on the right has 4 requirements. The first is a item drops signal bus. If I click here, we can create a new item drops signal bus. So when you have different objects connected to a signal bus, they can each subscribe to and receive data from the signals that are being emitted across that bus. So for instance, if you have, let's say, a game log, and in that game log you want to write a notification whenever a player picks up an item, then you can give it the same reference to the signal bus as the one we're assigning to this pickup here. So if everything shares the same signal buses, then they can all share the same data whenever an item gets picked up. So for that reason, it's a good idea to create one item drop signal bus, and you can right-click, save it. I'm going to save it to my signals folder in my project. So item drops signalBus.tres. Okay, and now anything else that needs to know about when this item is picked up should just have the same signal bus referenced, and then you connect to the signals on that bus the same way you would any other signal-based object. So now that I need any other object to know when this object is picked up, I would just reference the same signal bus, perhaps in the UI, and then connect to the signals within that signal bus so it can receive the data when the event happens. In this case, the item, the grass, being picked up. Okay, the rest of these are a little bit simpler. So free on pickup is which node do you want to free whenever this item has been successfully picked up. So generally that's going to be the root of the scene. So that's this grass, the rigid body 2D node. The reason it's that is any other children object get freed up automatically when you free the root. So let's assign the root here, which is grass. And then resource count. So this pickup represents how many of the item which you are picking up. So pickup resources, the property here takes any resource you want to assign here. Depending on which inventory system you're going to use, which is separate from the item drops plugin, you might have a specific class name for items inside of those inventories. So in that case, if you're going to be adding to an inventory, and that inventory requires a specific class type, then you should make sure that the resource you assign here is actually one of those. So for instance, I started working on my own inventory system. I'm calling it Flex Inventory. And in that inventory system, items are class name item. So if I want to create an item and assign it here, I would right click in my items folder, go to create new resource, search for item, and then we have item and item stack. I want item here in this case. So our item is grass. We're picking up grass and adding it to the inventory. So I'm going to type in grass or grass item. Let's save. And then we can see the item over here on the right has several fields. I'll just define those real quick. So grass. For the icon, I'll use the grass PNG, the same one that we're actually showing here. I'll leave tags blank, and let's say the stack maximum is 1,000. So now we can take this grass TRES file, which is a resource file, and just drag it and assign it to pickup resource. So when this component is called to be picked up, it's going to try to send one grass item over to whichever character is trying to pick up the item. Okay, now let's save this in our project. So the actual 2D scene, I'll put under, let's say, objects, and let's do pickups. So grass.tscn represents the pickup within the game world, but grass.tres is the resource item that represents the data that that pickup holds. Okay, now that we've done all that, we can go back to our drops component and just drop in the grass.tscn inside of the droppable drop field, which takes a packed scene. So we have a 100% chance to drop this scene into the game world, which, remember, the root is a rigid body 2D, so that should interact with physics. So now we need a scene spawner, which actually defines how the object gets placed into the game world. So in Item Drops plugin, there's a few different scene spawners. So in this case, I'm going to want a launch force scene spawner because we're dealing with a rigid body 2D and we want it to interact with physics. So I kind of want them to pop up above the player and then drop down to the ground and spread out on the ground for the player to pick them up. There are other scripts in here like shape edge scene spawner and spawned moves on spawn component, which can give you more of a kinematic body style of movement. And these are scripts I'm going to continue to work on and add more to as well, kind of as the plugin develops. But for right now, we'll use launch force scene spawner. So I'm going to go to the root here of swordsman enemy, right click, add child node. And if we type in spawn, we should get our options here. So what we want is launch force scene spawner. So if we create that, you'll see that this is a 2D node. Since it's a 2D node, its position is going to be relative to its parent. So you should make sure that its parent is actually a 2D node as well, so that when objects get spawned, they get spawned at the expected location. So if we take our launch force scene spawner, we can hit W to go into move mode and just position this to where we want the items to pop out of. So we could say right around his chest can be the offset for the transform. You can also expand transform and see exactly where we're setting this. Since it's a pixel game, let's make it -13 exact and just be precise with that. So this scene spawner is going to add a impulse force to each object that spawns as soon as they spawn. And the force is just the numeric value of how strong that is. The direction is going to be what's the base direction for where that's going. So -1 in Godot is actually up on the y-axis. So if we want these to launch upwards, then we would have those be a -1 here. Now the angle is going to be the spread for basically how much that direction can vary. So if you have a 0 angle, it's always going to be straight up, but you might want them to spread out a little bit. So if you have a 45-degree angle, that means 22.5 degrees to the right and 22.5 degrees to the left. Each item that spawns will be somewhere between that arc. Really, I would say it's easiest to just kind of start with the defaults and then adjust the parameters as needed to make it have the effect you're looking for. And then down here for all scene spawners, there is a spawn parent group that these objects can be assigned to. So the object being added into the scene, if you want them to appear under a specific group in your level, then you should make sure that your scene has a node with this name inside of the scene. So if we go to Woods level, I believe I already have one here. So just a node 2D here that's been assigned a group name. You can see the groups that this node is in, spawned parent. If you want to add a node to a group, then you just select the node. You go over to the node tab next to your inspector on the right. And then in groups, you make sure that it's in the scene groups or global groups, whichever you want to assign here. So as long as this matches by name, then when this spawner creates an item into the game world as a 2D scene, it's going to add those 2D scenes to this node as a parent. And remember, we're talking about the group name, not the actual node name necessarily. So that's almost good for the enemies setup. The last thing we need to do is actually set our trigger moment for when the items actually spawn. And then we tell the drops component to spawn. So that would be like spawn drops on drops component, which will use the scene spawner. And I haven't assigned the scene spawner here. So drops component, make sure you do assign the launch force scene spawner. Okay, that's all you need to do there. So that means that this is the particular scene spawner that the drops component will use. So finally, for actually calling spawn drops on the spawn component when your death event happens. So one way would be to actually add it to the death animation itself. So in animation player, you could add track, call method track on the drops component. And then down here at some point in the animation, you just insert a key, call the spawn drops method, open, and then that should drop the items. So if we hit play and defeat one of our enemies, then we'll see that they actually do drop the item, which is very small. And also it kind of interacts in a weird way with our player because they're on the default layer mask and collision mask of 1. Which means that it's actually blocking our player's movement here. So that's not how I want items to necessarily interact. And we can easily fix that. So let's go into the grass scene. So grass.tscn. And we want to expand the collision so we can see the collision layer and the masks. So for the grass, I want to take the physics off of the ground layer. So I'm going to undo ground layer 1. And I can actually click over here and we can see the different layers in this project. So I want my pickups to only be on the pickups layer specifically, so that only a specific type of interaction, which is that the player picks up an item, is going to occur, and the regular physics is ignored. For the mask, I do want to leave the mask set to ground, so that the grass can still collide with the ground. Also, we can see that our sprite is really tiny. So if I zoom out, this purple box is our viewport frame, and this is our item within that frame. So I want to take the sprite 2D, and I'm going to increase its scale, let's say to 4 or something, just to make it significantly bigger on the screen. And then we can save it, and that should be good. I also want to go back to enemy generic, and then on the death animation, I'm going to remove the call to drops component here so I can show another way of doing it. So I'll just select the drops call here and remove it. So that probably is the easiest way to do it. And I'm instead just going to add it to my death state. So this is very much depending on what kind of state machine or enemy logic you're using. But basically when the enemy transitions to a death logic or death state, you want to call the drops component. So for my particular script, I'm going to be adding in a reference to the drops component. So export var drops component, drops component. And I'm also going to say how many times I want the drops call to be made. So I'll say export var, let's say drops count, and that'll be an int. I should default that to 1, because you usually want to have at least some drops. So I'm going to take a look up at my state machine states. So I'm going to go to movement state here, and then animation node state. And I'm going to see the different virtual functions that my state machine implements. So I want OnEnter here. So when a state is entered, that's when I want to call a DropsComponent spawn drops. So if I just kind of copy this over here to the death state, paste this in. So this will be called in place of the original function. Then basically when OnEnter happens, I can start by calling super and then pass in the parameters here. And this will make sure that any parent classes that have an implementation of OnEnter will also call whatever they were doing before we run this script. And what I want to do here is just DropsComponent.spawn drops. And I want to do that with a drops odd multiplier of the default 1.0. Because I have no multipliers, there's no items that the character has equipped. And then all I really need to do here is do DropsComponent.spawn drops. It has an optional parameter for odds multiplier, defaults to 1.0. So if you don't want to mess with the chance of drops, then you can just leave that as the default. And I need to call this once for every drop count. So let's put that in a for loop. So let's say for number in range 0 to drop counts, and then we'll do increment by 1 as the third parameter every time. Okay, and then we just tab this over. So for the range of 0 to the maximum size of drop counts, we're going to spawn the drops. So basically this gets called whatever this number is times. I'm also going to say drop count instead of counts. That makes more sense. And that's basically our death state logic here for spawning the drops. So a little bit more involved, but you can see obviously you can do it with your code as well as just calling it on the animation player. So I'm going to assign the drops component to the death state, just like that. And now it knows where to call spawn drops on. And let's take the drops count and bump that up to 12. And finally, we will hit play and test that this is actually working. So we hit play. I'll hit them a couple times, and then we get all of our items spawned onto the ground. You can see that because we took it off of ground 1, our player that also collides on ground 1 does not collide with these objects. But these objects, because they're masking layer 1, they do collide and stick on the ground. Now, these grass are way too big. I'm probably going to lower this scale to 2. So let's go back to that. Scale 2, scale 2. Also in the 2D scene, we probably want to make sure that this collision sprite is a little bigger. So let's say 4 or 3 pixels. 3 pixels seems to be perfect here because it goes from the top part to the bottom. You could also use a different shape if you want, like a rectangle, if you just want that to go like completely around the object. But if you do make a collision shape that's this big, well, you might have objects bumping into each other. It's just something you kind of have to test. But let's see. I think the grass actually can't collide with the grass, so that's actually fine. But the problem with the rectangular collision shape here is that they don't roll on the ground. So if you want that rolling on the ground, then yeah, go back to the circle shape or a capsule shape maybe. So it's really up to what you want, like how you want it to interact in the game world as a rigid body. This isn't really a physics tutorial, so I would say just play around with it and see which shape works best for you. So yeah, our enemies drop the items whenever death state is entered, but our player can't really pick them up yet. And there we have like one item glitching into the wall, so maybe we need a bigger collision shape to make sure that doesn't happen. But what we really need now is the player to have an inventory and the player to actually pick up the item. So on our player, which I'm calling Sword Hero, we want to give it a component, right click, add child node, and we are looking for a pickup collector component, pickups collector. So we add that in, and this, when it encounters a pickup on the trigger area, which we have to create as well, of course, then it's going to try to pick up that item and add it to the player's inventory using this method name that we have assigned here. So it's a generic call to whichever inventory you're using. Since item drops is not an inventory system, it just basically sets things up for picking up to an inventory. So if you have a different method name for your add to inventory, you can just put the name in here like add. I default it to try add because not necessarily every time you try to add items to an inventory would it be successful. The inventory might be full, for instance, or it might not allow that particular type of item. Basically, the requirements here is that whatever method you're calling takes two parameters. It should have a resource, which is the item you're trying to pick up, and then it should have a count for that resource, how many of the item you're trying to add to the inventory. And then it should return either a integer or a boolean. Boolean for the success for whether it added or not, or a integer for how many items were added to the inventory. So if it returns an integer and all of the items were picked up, then it's going to remove the pickup from the scene. So this part's actually a lot simpler than everything else we did so far. We need to add a area 2D that can detect pickups. So if we right click on Sort Hero, add a child node, area 2D, and we could just rename this to be pickups area 2D if we want. Every area 2D needs a collision shape to define where it can detect things. So right click, add a child node, collision shape 2D. And let's make that a circle shape. Make that big enough so that it makes sense for the player. So anything that the player encounters in this radius, we can say is valid for trying to pick things up. So on our pickups collector, let's assign that area. And then on the area 2D, let's assign the collision layer. So our area 2D is going to be looking for pickups layer 7. And that's it. So I'm going to turn off the other layers. The area 2D does not need to be monitorable because it's only looking for pickups. Nothing is looking or concerned with this area. You don't have to turn this off, but you can. It's just currently unneeded. And that's basically what we need there. So just make sure that the layer for your pickups is the one it's masking so that it can detect characters or objects on that layer and try to interact with it. Then for pickups collector, the pickup inventory. So this is any node. So you're going to need an inventory script of some kind, and it should be represented as a node. So I'm going to right click on Sort Hero, and I'm going to be looking for item container. If you've used my other plugin, Grid Builder, then Grid Builder Inventory would have a item container class. This item container is actually the one from Flex Inventory, which is going to be more of my main inventory system for my own games going forward. So on Sort Hero, I'm going to right click, add a child node, and I'm going to look for whatever my inventory class is called. So in this case, item container. And if you were using Flex Inventory or Grid Builder Inventory, this is what I'm calling it. So I would create that. And then I just need to make sure that the pickups collector is calling try add or add on this item container. So I'm going to assign the item container. And now it's going to try to run the method try add. We could take a quick look at the script here actually. So on the inventory class, which is generic, so we don't actually know what this class is, but it's a node and we're trying to call the add to inventory method. That's the name of the method. And we're passing in a pickup resource and the number of resources that we're trying to add of this type. And we expect it to return some results. So for results, so currently I have it handling Boolean and integers if it picked up an item, if the results were add successful, or if items were added, basically the integer representing how many items were added, then it will be successful and we can run pickup on the pickup. And then also emit a signal from this class that this item was picked up if any other objects are concerned with that. So the item container class has the try add method, so it should work just fine here. I'm going to hit play. I'm going to hit some enemies. And as I run into those items, we can see that those are picked up. They're added to our player's inventory. Now, there's no indicator on screen to see that. So I can keep the project open, go to remote view and find our player. And if I open up the item container slots, then we can see that this item stack has 12 units of grass. But you probably do want some kind of visual indicator for items being added. So this would be where you'd create a view that can read into the item container on the player. So in my UI, you can see, okay, so this part isn't really part of this tutorial, but more like what I'm working on with the Flex Inventory system. So in my UI, I have a resources view, and you can see the base one just needs a item container here. But to assign the item container, the player has to be created within the scene already. But you can see that in my world, the player isn't loaded until the level loads. So to get access to that, my game state signal bus basically emits whenever a new player is spawned into the scene. And then this script can reference that player and assign the container whenever that event happens. So what I need to do on my sword hero is just to assign the inventory. So on my base player script, I assign an inventory, the item container. And now when that signal is emitted in the game state signal bus, my resources view will be able to read that. So the item container view is just a sample class from Flex Inventory. The player resources view is just extra stuff I coded on top of that, so it's not actually part of the plugin. And then the player resources view is just inheriting from that class, giving it access to the signal bus, connecting to the signal, and then when the signal happens, then the container is assigned. So we have the item container on the player. When the player spawns, this view should show the items in the inventory whenever they're collected. So now if we hit play and defeat a few enemies without collecting the items, then you'll see that we can run over them, pick them up, and they'll be added to this inventory view over here. So this is just the UI showing the display whenever the items get updated, but on the player itself is actually where the inventory is being held, so to speak. Okay, so now if we hit play, we can defeat enemies, and you'll see that when we collect the items, they're added to the inventory view over here. Really, the inventory is on the player node itself, but the UI is referencing that through signals. So that's one of the things you can use the signal bus pattern for, which is pretty handy, I think. So this tutorial was pretty long, obviously, but hopefully that goes ahead and shows how you could, for instance, have an enemy, when defeated, drop items onto the ground as a spawned scene, and have a player pick up those items and add it to an inventory. There are a lot of steps involved here. For instance, you have to create the scene for the item. You have to create a resource for the data representation of the item. Your enemy needs a triggering event like a death state in order to spawn the items, or you can just call it on the animator. That would also work fine. And then the player needs its pickup component, an area to detect the pickups, and then an inventory to add it to. But once you have everything together, hopefully you can get the desired result, and then just show things through a UI after you connect your UI to the inventory in one way or another. So I've been Chris. I hope this tutorial has shown you guys a lot of what the Item Drops plugin can do. Thanks for watching to the end, and I will see you guys in my future video content.